In this video, we're going to be talking about jobs and cron jobs. As you can see, I'm not here because I'm at KubeCon, so I'm just going to make this a really quick video. Let's get going. Let's start with jobs. A job is something that you want to run as a one-shot to completion. An example of this would be if you had a website that needs to do something based on a trigger. Maybe you have a bunch of batch work you need to do, or maybe you need a one-shot thing to run when a particular event occurs. A job will allow you to do this, and they run to completion, unless they fail, but that's another thing. Another example might be if you have an operator. Again, we'll get into these later. And as part of that operator, you need a bunch of CRDs to be deployed. Again, we'll get into those later too, before the main system runs. In these cases, a job can do, well, the job. In our example though, we'll just use what's on the Kubernetes website, as you can see here, and that will just show you how it works on a basic level. This example just here counts pi to 2,000 places. It's a little Perl script that runs, and that's it. We'll copy and paste this in. So I'll just grab this and jump over to my IDE. We'll create a new file called job.yaml, and we'll paste that in. Before we run it though, let's take a look at some of the settings and what else we can set. So the first thing to note is this template. This should be pretty familiar here from the last video. It's the same as it is in deployments, daemon sets, and stateful sets. This here is just a template for the pod. It's a basic job spec, that's it. We also have this back off limit. This is how many times the pod will retry if a failure occurs before giving up. We can also set the job to be a parallel job, which we won't deep dive into here, but if I jump over here, we can see the parallel execution for jobs. Now, this will give you a bit of a write-up of what's going on, just to kind of summarize it in a nutshell. We can have jobs run alongside one another, either using fixed completion count, which means once that number is hit, it's classed as done, or as a work queue, which requires some external system to determine what pod does what. An example of this would be having to process a large amount of data. Maybe the data can be broken up into chunks for the work to be done, and each pod is responsible for a specific chunk. A really crude example of this could be sending a mass email. Say you have 10,000 emails to send, and each pod is then responsible for sending 1,000. We can also configure a failure policy, as shown here. Now, the failure policy allows us to catch certain scenarios. So in this example, it's saying if a pod hits 42, then the entire job fails. Any other exit code would be fine. And it's basically catching that specific one. So if your program has a 42 exit code, the job will pick that up and say, this is a failure. This bit here, as you can see down here, specifies an ignore action for failed pods with a condition disruption target. And that basically excludes pod disruptions from being countered towards the back off limit. So imagine a node goes down halfway through a run. Well, this means that the back off limit counter won't go up by one, which means when it reruns, it will still be that same count of the previous run. So say you're on retry number 2 and the node goes down. Then when it comes back up, the job would start again and it would basically start at number 2 again. That's what it's for. So it's good for, I guess, giving you a little bit of protection against node drains and recycles and things like that. Okay, that's pretty much it here. There's a little bit more, obviously, to go on with jobs here. You can see the lot down the side, but we're just going to go ahead and deploy that pod now and watch what it does. So I'm just going to go here and do kubectl, get pods, name learning. In fact, what I'll actually do is I'll get pods and jobs so we can see what's going on, and we'll watch that every 1 second. There'll be nothing there at the moment because I've not actually deployed the pod yet, so I'll just go ahead and do that. Before I do, set the namespace to be learning. And now we'll just go ahead and do kubectl apply f and the name of that folder, which I really should rename because it's a terrible name to remember, and jobs. So if I quickly hit enter, I'll jump back over to the terminal and we'll see what's happening. So we should see that job gets created, which we can, and the container is now being created. We'll just give that a few more seconds to go up. Okay, that took like 1 minute and 9 seconds just to pull the Perl image. That must be a really large image, or my internet is not working very well. But as you can see, there's a pod here that's been created. It was then completed, and now this completions has gone up to 1. Let's quickly just go and take a look at this particular job. Okay, so we'll do kubectl describe job, and the job name, which I don't actually know. There we go. It's just pi, okay? So let's describe job pi. And as we can see here, we have 1 succeeded, and then pretty much just everything else you'd usually see. You know, we've got the pod template and all the information within it, the commands that will run. We have the completion mode, which is just non-indexed, and we have parallelism is 1, completions is 1. It's you know, you can see pretty much what's going on there anyway. So if obviously you had it active, it'd be active. If it failed, this failed number would go up, and you've got this succeeded here. We can also handle the automatic cleanup of these jobs because pods that are created as part of the job I'll just quickly show you, get pods, namespace learning. These will just hang around. So we can do things like handle the automatic cleanup, as I say, which means that after a certain number of jobs have run, maybe you've got a max of 5, it will then start deleting the 6th one that you run, essentially. So the 6 in terms of age. So the first one would be fine, the second would be fine, the third one would be fine, the fourth one would be fine, the fifth one would be fine. And then when it comes to run 6, it delete number 1. So you've always got 5 sticking around. That's essentially what would happen there. We're not going to be doing that right now, but again, in the docs, it's all there, which, as you can see here, it's suggesting cron jobs are the things to use. Basically, that's what it's suggesting anyway, because those pods will hang around. If you delete the job, the pod will disappear. So I'll just quickly show you that. We'll do kubectl, delete job, namespace learning. And I actually need to provide the name, which was pi. Now, if I get the pods, you'll see there's no pods left over. But as it said, ideally, we want to use a cron job to clean up. So why don't we just go and take a look at that instead? I'll jump over to the cron job section. Actually, here, look, you've got automatic cleanup for finished jobs. There is other ways of doing it. It will give you information on here if you want to, but we're just going to go over to the cron job section. And well, here's one right here that we can just, copy and paste. Good developers copy, great developers paste. There we go. So we'll paste that in. Now, if you don't know a lot about cron jobs, I'm going to quickly run you through. So we've got a namespace we need to enter there, so we'll just quickly do that. But we're naming the cron job hello. We've then got this schedule, which I'll come back to in just a second. We've got the job template this time, which is the same as the job. So it's basically this put into here. And then inside the job template, which has a spec, we have the pod template. And again, with this, there's plenty of options to look at if we want to. We can look at time zones, concurrency policies, deadline for delayed job starts. There's quite a bit you can do here. So we can do history limits, which is what we were just talking about a second ago. These are the bits that denote how many are kept behind. By default, it's set to 3 and 1, respectively, for history limit and failed job history limit. That means that any successful jobs, you'll get 3 in the history, and any failed ones, you'll keep 1. That's basically it. We can automatically clean up jobs. So let's go ahead and jump back over to the cron job, because you can read through this. It's pretty short in the scheme of things, and it's pretty straightforward if you know about cron jobs on Linux already. If you don't, I recommend you go and look at it. I don't think I have a video on it yet in my other series, but at some point I will put one up, so there may or may not be one there by the time you look. But if you're watching this video as it just comes out, I'm telling you now, there isn't one. So I'll quickly run you through. So the way the schedule works is this first star means every single minute. Second star means every single hour. The third star means every single day of the month between 1 and 31. The fourth star means every single month between 1 and 12. And the last star means every single day of the week between 0 and 6, which I think goes Sunday to Saturday. 7 is also Sunday on some systems, depending. So basically it goes Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, but it's numbered 0 to 6. So what we could do is do something like we want it to run at 36 minutes past 2 in the afternoon. So it goes between 0 and 23 for the hour. The day of the month, it's going to be the 5th, and we're going to do the month itself to be April, so the 4th, and the day of the week would be, I don't know, let's go for Tuesday. So Sunday, Monday, Tuesday would be 0, 1, 2. Okay, now you wouldn't really do this because you would have to rely that the 5th of April is a Tuesday for it to work. So you may not want to do that because you might get it to run once every few years if the 5th of April is every Tuesday. So yeah, don't do that. What you could do is have something like that, which means any day, doesn't matter what day it is, run it at 36 minutes past 2 on the 5th of April. Or alternatively, you could do something like run it every Tuesday at 36 minutes past 2. So there's a few things you can do there. You can also do other little tricks like every 5 minutes, which I'm not going to get into right now. Have a look at crons if you want to. But for now, we're just going to do every single minute, every single day, every single hour, every single month, everything. So we'll just do that, and we'll go ahead and apply that now. So what I'm going to do is jump back over to the terminal. We'll do that watch command again, but this time we'll also include cron jobs. So we'll do that. We'll then go back and apply this. Jump back over and we'll see the cron job created, and it will need to hit the top of the minute. It's not just going to run every minute from the second it's deployed. It will run at 00 up here. So I'm just going to wait for that time to pass. Okay, there we go. So I say it'll run at 00, by the way. It's as close to the time as possible. It's not going to be exactly on the minute. For example, I think this one ran at about 3 seconds too. So yeah, like 57 seconds past. It will be as close to it as it can. So as you can see, we had a cron job created, which was there from the start. We then had on the minute a job created, which created a pod in turn. Now these will work in exactly the same way as the job that I just showed you. You'll have a completion status, as you can see here. You can see the pod is noted as completed, and that will just sit there now. I'm going to let it run for a couple more, and then we'll take a look at how things are starting to change. Okay, so here's our third job just being created. Now what we should see on the next run is this job here, this pod, should get deleted, and this job should be deleted too. So we'll just wait for 1 more minute to pass, and then we can call it a day. So let's leave that to run. So this should start any second now, and there's the new one come in, and oh, there we go. It deleted. I was a bit worried then. I thought it maybe wasn't going to do it. So it just took a second, but the cron job then deleted the old one. And that's it. There we have it. So there's cron jobs. So that's everything you need to know about jobs and cron jobs. In the next video, we're going to be talking about metadata, as in annotations and labels, or services. I've not decided which order I'm going to do them to in yet, so it'll be a bit of a surprise for you when you eventually load it up. So I'll see you in the next one.